So this example in your notes page 141 continues working with dividing a line in a given ratio. However, this time instead of having to work out the point that's between the two endpoints, you're having to actually work out one of the endpoints. So we've been told that we've got 3 points A, B and C which are collinear, and we also know that the point divides the line in the given ratio. So we've got our point A and we've got our point B and C, and it's B that divides the line AC in the ratio of 3 to 2. So we would be looking for a little diagram to help you think this through. So that's what we know. We know that this time we know the point A, we know the point B, and what we're having to work out is the point C. So the method, you were introduced to two methods for working with these sort of dividing lines and ratios, and I'm going to say this time it's probably easier to use the position vector method where you're thinking about the ratio to begin with. So if you think about the A to B compared to B to C, right, is equal to 3 to 2, and then do the little cross multiplying step here. So we get 2 times A to B would be equal to 3 times B to C. And what we're trying to work out, remember, is this point C at the end here. So it's at one of the end points. So it's easier to do this probably rather than the section formula. You can still do the section formula, but it's a wee bit harder because you need to form equations. So this here lends itself quite easily to saying position vector A to B is B minus A. So 2 bracket B minus A must be equal to 3 times C minus B. And from that we get 2B minus 2A equals 3C minus 3B. Now we're going to try and it's the C that we would like to find the position vector of, because if we get the position vector, we'll then be able to get the coordinates of the point. So ideally, if we isolate that 3C term there, so if we take that 3B across to the other side, we get 5B minus 2A is equal to 3C. I'm just going to switch that round and say 3C equals 5B minus 2A. Now I could divide by 3 here and then I'd have fractions and things involved, but I'm going to say it's easier to just work with the whole number parts of this first. So for the position vector for B, remember that's the coordinates for the point B, which were 13, 5 and minus 7. Minus 2 times the position vector A is the coordinates of A, so you've got 7 minus 4 minus 4, and that then gives us the vector. Multiplying that out, you're going to have 65, 25 minus 35, and this one I'm going to give you 14 minus 8 minus 8, and then you end up with 3C will be equal to 51, 33, and we'd have minus, this is minus 35 minus 8, so that becomes plus 8, so that's going to be minus 27. Now remember, this is what 3C is equal to, so C will need to be divided through, and we get 17, 11 and minus 9. Remember what you were asked for was the coordinates for the point C. So coordinates of C will be 17, 11 minus 9. So that method of using the ratio of the lines, or directed line segments to each other, and then cross multiplying. Then using position vectors is a good method for when you're trying to work out an endpoint. So there's an exercise to work on and practice more of this sort of idea.